Welcome to Qt Widgets and More. In today's episode, I'm bringing a co-star, namely Pepe, also known as Giuseppe De Angelo. Pepe is gonna answer a very simple question. I'll bet you he'll spend a lot of time on that, namely, what classes of string inheritance should I be using in Qt? Welcome, Pepe.
Hello, everybody. Hi, Jesper.
I have a question. Actually, let me start telling you a funny little story. At least it was funny to me. Back in decades ago, when Nokia took over Qt, I went to a training in Symbian. I don't know if you remember Symbian at all. That was the operating system running on those Nokia phones that wasn't that smart back then. And in that training, which lasted 2 days, I spent a whole day talking about the many different string classes that was available in Symbian. Now it feels a bit like we are there with Qt. We have QString, we have QString literal, we have QAnyString view, we have, I don't know. Can you tell me what should I be using all of these for and when should I be using them? And can you keep that really short?
Okay, I'll try to keep it really short. If you want just one answer, the class that you want to use and you are going to use, let's say 95% of the time, it's simply going to be QString. That is the class to store, manage, manipulate strings inside Qt. Of course, the name says it all. It's called QString. And that's the one you're going to use most of the time. All right.
Okay, that's it. I just wanted that on video. Thank you very much. And in the next week's episode, I guess not.
Bye. Oh wait,
and
there is
the
more.
Slightly more elaborate answer is.
Okay, let me go a little bit more in detail because right, you can make fun of Symbian for having I don't know how many string classes, but no, the truth is actually also Qt has lots and lots of different string classes, string views, string utilities. There is a whole collection of things that kind of work together. But of course, why so many? Because each one has a slightly different use case, or it enables a particular optimization and stuff like that. We write C++, and although we don't necessarily write code with the performance in mind the entire time, but we still like the ability to say, okay, now I need to optimize this code and I have all the tools I need to do that. And that's why we have so many things around. So what I've done here for you, you can see now on the screen, I've compiled a little table in which I've arranged the various things, the various classes, and also some other utilities that are available in Qt when it comes to storing string data, manipulating string data, accessing string data. All right. The major class, as we discussed, is QString. That's the class you're going to use most of the time. And the class that you did mention, QString literal, well, that's not a class, right? That's just a little macro that it allows you to build a QString out of a string literal at compile time. So it's convenience. It's another form of optimization. If you do have a static string, something which is hard-coded inside your application, why should you pay for building that string at runtime if you can do it in advance at compile time? So it's a nice thing.
So just to prove to the audience here that I'm not a total noob, I hope that's the right pronunciation of that word, otherwise I'm a total noob. I actually had a very urgent need for QString literal way back then. It was in the Q3 days. I was passing some XML file using whatever mechanism was in. I think it was QDOM, and I got an element in, and I checked whether the element was image or if it was tag or whether it was file name or whatever all my elements was called. And I did so in a loop where I read in the next token from the XML file. I compared that to a string, and actually the comparison created a QString behind my back, and profiling turned out to be enormous amount of work. So that was in the Q3 days, and I was yawning for getting a QString literal that could put this in at compile time. So that's a good example of using QString literal, right?
That is one possibility. So if you want to compare strings together, so a string that you of course build a runtime against a compile time string. Although I must say that these days there is no longer even the need in such a scenario. The reason is pretty simple. Throughout Qt3, then Qt4, then Qt5, the equality operator for QString got overloaded with several overloads. So of course you have the equality operator between the two QStrings, but you also have the one between a QString and a const char star, between a QString and other string-like classes like QString view, QLit in one string, and so on and so forth. So today, if you were to write the same code that you were writing in the good old days, you would actually pick up the equality operator between a QString and a const char star, and that equality operator does not allocate memory, does not build a temporary string in order to perform the comparison. It will actually just do the comparison between your QString that you have and whatever char star you have on the other side. So it's a kind of improvement, right?
What I hear you say is that if we put aside anything about internationalization and translation and whatnot, then a char star in quotes, a string in quote, that's not an evil thing anymore.
It is not an evil thing anymore for things like, of course, comparisons, but also for building strings. If you just have QString as equal hello world, again, taking considerations such as internalizations aside, no, that's completely fine. Of course, I must warn everybody watching this video, this is completely fine today, in which we live in a world where we have, for instance, accepted that the de facto encoding for everything is UTF-8. And we made a number of decisions in these years that now, of course, have affected the design of Qt. But again, back in the day, like in Qt3, this was not the case, right? Even a char star inside, even a string literal inside your source code, you didn't have any guarantee that, for instance, Qt was going to interpret that string as an UTF-8 string. Actually, there were switches and functions that you could call inside Qt to configure the behavior. So how to decode exactly a string literal into a QString. Should I read it as a UTF-8 data, as a ASCII data, Latin1, Windows code page 1252? You could choose, right? That's the problem with encodings. There are just too many and everybody took their own decisions. And of course, this caused a lot of pain and a lot of incompatibilities. Thankfully, the world is kind of deciding to go with the Unicode and UTF encodings. So these days it's much simpler. You just use a char star, a string literal, and unless, again, you're looking at micro optimizations or stuff like that, you're not doing it too much wrong. It just works.
So in your table that we have here on the screen again, I also see that you're mentioning byte arrays, which I guess you could think of as a string, though. Yeah, I guess. When would you ever get to a byte array? I mean, if I were to read in a file, I would wrap that in a QText stream as fast as I could and set the encoding on the text stream and see QStrings again.
Yeah, there are a couple of situations in which you deal with byte arrays. Generally speaking, you're right. I/O, input-output, in general is a situation where you deal with raw bytes. So whether it's a file on disk, whether it's a network socket, whatever it is, what you get from disk and what you write into disk are raw bytes. And so you need a class that is able to store that kind of information, and that class in Qt is QByteArray. Granted, of course, you typically don't manipulate raw bytes yourself. So if you have some sort of a file containing some data, you can use QByteArray to read the contents of the file as binary data, but then you're going to feed these bytes into something like, QText stream. If you have some sort of text file, if you have a JSON file, you're going to feed them inside a JSON parser, XML parser, or some other sort of parser that is able to manipulate this binary data and give you back, either QStrings, in case you're decoding strings, or whatever kind of objects you want to extract out of that binary data.
Just before you killed off the need for QString literal, more or less, how about QLatin1 string? And Can you tell me what is the relationship between these two?
Right. There is one important consideration that I must do regarding Qt-Latin1 string. That is, it is a class which has got a wrong name in Qt. In fact, if you take a look in which column I placed Qt-Latin1 string, it's not in the same column as QString or QByteArray. It's in the right column. The column is also called the view classes. So we can discuss in just a second what a view class it is and what are these use cases.
Yes, please.
But yeah, in a nutshell, a view class is a class that does not store the data, the string that is referencing. It's just really something like a pointer and a size into a string which is someone else. So Qt-Latin1 string, which by the way got finally renamed into Qt-Latin1 string view, coming in 6.4, I believe. So now it's got the proper name. It's a view over a Latin1 encoded string. Where do you use it? Typically, you use it to build strings or to compare strings. When you have, for instance, a QString and you want to compare it against a Latin1 string that you have built at compile time. Qt can make use of this information. That is, you're telling Qt, look, the string I have at compile time here is not UTF-8, it's Latin1, and I'm telling you this, I'm guaranteeing you that. And so that, for instance, Qt can do a better optimization job, because comparing Latin1 data is, generally speaking, faster than comparing UTF-8 data. So now we go into the realm of, okay, if I do have some sort of tight loop, like one that you mentioned, where I'm doing some string parsing, I'm comparing a string, a candidate string against a bunch of candidates, and I'm doing that in a loop for millions of strings, millions of tokens. I really want to optimize this out. Then here's Qt that comes to my help and tells me, okay, you can use just a char star there, it will work. But if you even want to squeeze more performance out of that, given that your tags are likely going to be just ASCII or Latin1 anyways, then wrap them inside this view class. Wrap them in Qt-Latin1 string, and I can go even faster. Okay, provided, of course, that they do are ASCII, but you know, XML and similar formats are typically ASCII based, so there is no problem.
Okay. Let's talk a bit more about views now. That you have mentioned that word a number of times. That's it wasn't new in Qt 6. It was already in Qt 5, right?
Yeah, in Qt 5, even Qt 4, we had a specific view class which was called QStringRef. Okay. So that's again the same concept of having just a pointer into some string data and asides. So this allows you to have, as the name says, a read-only view into some string data, and the string data itself is owned by someone else. Now, QStringRef is gone for the simple reason is that it was too tied with QString itself. So specifically, in order to build a QStringRef, you needed a QString all the time. This was deemed to be too limited, because in general, you may have a view over some other string-like data structure, like for instance, just a plain array of bytes, a standard string, anything like that. And that's why we got more string view classes coming Qt 5 and then Qt 6. So somewhere alongside Qt 5 history, QString view and QByteArray view got added. Okay, QString view is a view over QString-like data. So UTF encoded, UTF-16 encoded to be specific. QByteArray view is a view over raw bytes. No encoding, it's just binary data. Okay, the point of these view classes is once more to enable, on one side, more optimizations. Okay, and by that I mean there is a huge number of use cases in which you may want to just return or process views into a string that you have. Let me give you a very practical example. Suppose that you have, a big long string, like, a file system path, and you want to return each component of this path. Okay, so like each directory, each level. Now, you could easily do that by, splitting on the directory separator on the slash and returning me a vector or a list of strings where each string corresponds to each level. However, by doing so, you are allocating a lot of memory. because you are not only allocating, of course, something like the vector to contain the strings, but each and every string, each and every token that you have split in this way is also an QString, which means it's also an allocated string somewhere. Okay, so that process of splitting a string is going to incur in some performance penalty. And of course, if you do it once in a blue moon, yeah, whatever, right? Just use all the convenience in the world. But if this is a critical part of your application, okay, can I do better than that? Okay, that's the question that comes to mind. And yes, you can do a lot better than that. For instance, if you never need to store these strings or you just need to process them, you could ask to split the string, but every time each token gets returned to you as a string view. So what you are doing basically is isolating each token within the bigger string. And every time I give you a chance to process each token as a view into the bigger string. So I'm going to tell you, okay, that's the first component, it's this part right here. That's the second component, that's the third component. By doing so, you're not allocating any extra memory, because all you're doing is just building pointers into the bigger string. And so you're saving a lot of, you're actually gaining a lot of performances out of such code. Okay, I hope that makes sense.
Yeah, absolutely.
Right.
So, but I guess one of the, and sorry for the noise in the background, that's what you get from recording from home. So one of the key thing with the view classes, I assume, is that they are just views on somebody else's data. And one thing you should be super careful about is lifetime of this. I remember in the good old days with qbyte array that could get you a let's in one string, and you would have that let's in one string and be happy and kill off the byte array. And how many bugs have we not fixed in that area for years? So any best practices around views that you?
So there aren't, strictly speaking, best practices available here, because this is just a symptom of a much larger problem that we have in C++. That is, every time we have a class, an object whose semantics, whose lifetime depends on another object, then C++ does not help us in any way ensuring that the string survives the string view. Okay, so in actual, we have to make sure that we do it ourselves. Other languages, very popular languages such as Rust, do have meanings, do have mechanisms for having the compiler tell us, wait a second, this is strong, this is weird, this is suspicious, don't do that. But again, we don't have that in C++. But if I...
So how about just doing what they do in Java? Let's get a garbage collector in there, and everything will be fine, right?
I will not dignify that with an answer.
Fair point.
But concretely speaking, the chances for you to do something wrong here are, to be honest, quite small. Okay, if I go back to the previous example, the tokenizer example, while you're splitting a string alongside the slashes or whatever components, you do have the string around at every time, at every round of the tokenizer. You're just taking a substring and you're processing that substring. So unless you're doing something like storing these views for long term, in which case, yes, you do have a problem of having the lifetime tied to this original string. Unless you're doing that, you should not have absolutely zero problems at start using views for these use cases.
Excellent. That, of course, leads me to the next question. Should I just go and do search and replace throughout all of my APIs, replace QStrings with QString views?
Okay, no, please don't do that. Okay, as I said at the beginning, 95% of use cases for QString are absolutely fine. And indeed, most of the time, you are passing the QStrings through API barriers because you want to transfer the string itself. Okay, consider something like QLabel set text. Okay, you have a QString with you, and you're giving it to the QLabel, and then the QLabel needs to store the string internally. What you want to pass to the QLabel is the string itself. If on the API surface you put something like a string view, okay, going into the setter would be super easy because you can easily build a string view out of a string. But then the label internally would have to reconvert the string view back to a string. So it's going to allocate memory for that step, for that conversion. Now you may be wondering, wait a second, but doesn't the copy between you and the label also cause an allocation? No, it doesn't when it comes to Qt data types such as QString, because QString is implicitly shared. So actually, the call to the setter is not going to allocate any memory whatsoever. It's simply going to bump the reference counter of QString. So it's actually super cheap.
Okay, fair enough. Can you give me an example then where I would want to do it?
Precisely. So I said, wait a minute, this doesn't mean that QString view is useless. On the contrary, QString view and in general view classes are actually very good candidates at the API level, at the API surface, so in functional signatures, for a number of use cases. To me, the one that is perhaps more interesting and easy to grasp is this one. Every time you got a function which has to take some string as input, but then it does not store this string in any way. It simply processes it. Okay, so it parses the string, or it converts the string to something else. Like, I don't know, you take a string and get out a number, for instance. In all these cases, you're taking a string in and you're not storing it. Okay, so if you have a function which takes this string in as a QString, you're basically forcing the caller of that function to allocate a QString and then get rid of it right away. Okay, I need to allocate a QString, I call your function does not just reads the string data, it does not store the string anywhere. Okay, and then the function returns and you have to throw away the string that you just built. That is kind of a waste. Okay, and it's kind of an API, I wouldn't call it flaw, but still a slight API mistake, because you're forcing your users onto a particular string type, a particular allocating string type, just because you made that function take a QString. Okay.
But, sorry, I don't get it. You say I should be using QString view instead of a QString, because if I use a string view instead of a QString, then I do not force users to allocate a QString. But isn't that the whole thing, that the string view is a view on a QString?
It could be a view over a QString, but it also could be a view on something else. For instance, it could just be a view over a string literal. Okay, let me give an example, a practical example.
Okay.
A function that we have, for instance, in Qt is a constructor, a function, sorry. Let me give an example. A class that we have in Qt is the class QColor, okay, which just represents a color, for sake of simplicity, RGB color. Okay, so it's got a red component, green component, blue component. Now, almost no one wants to build a color out of these three components. If you have them as numbers, that's good to go. But most of the time, you want to build a color out of a string of some sort. Maybe you want to build a color called, what's the name? Light steel, the one that it's always used in QML.
Light steel blue.
Light steel blue, right. Or just blue, or gray, or red. Or maybe your designer told you a specific string in hexadecimal, so hash 00FFDA, and that's the color that you want to use. So in order to build a color out of that, what you're going to call is likely a constructor or a named constructor of the class QColor, something like from named color. Okay, and of course you want to pass a string in. And here's the question: what is the signature of this function? So what kind of string you're accepting? If you are accepting a QString, then indeed you force the caller to have a QString to begin with. So of course, if the caller already has a QString, there is no problem. But most of the time, the caller is not going to have a QString for you. What the caller is going to have is just a char star, a string literal. So what the caller is going to have is something like that. Okay. Okay. So now this is forcing the compiler to do the conversion from that into QString, allocate a string, get the caller out by parsing the string, and then destroy the temporary. And this sounds like a complete waste. Okay. Now, sure, we could optimize this a little bit by using a QString literal around this. We could say, okay, this string is known at compile time. Let me build it at compile time. All right. But again, I'm still forcing the usage of QString specifically. What happens if this blue comes from another C++ part of my application which knows nothing about Qt? So it's just using the standard strings. Okay. The standard string classes. That's a possibility. Okay. So I would argue for this specific case, what do we have here? It's a function that parses the string, so needs to read the string data out, but it does not need that string to be a QString to begin with. Okay, so a very easy point to take here is that you can get rid of this and just use QString view in the function signature, just like this. Okay, and if you do that, sorry, let me get rid of that. Okay, so a function like this, which just takes a QString view, and if you do this, now you enable this function to be called with a variety of things. So if you add a QString, you can still call it. So that use case has not changed at all. If you don't have a QString, you can still call it, for instance, using a UTF-16 literal, or if you have a standard UTF-16 string coming from somewhere inside your application, again, you can call that using that S function. You just enabled much many more possibilities for that function to be called. And this comes to a virtual zero price for you. It's just a little matter of API design. And again, it's a very easy point to grasp. Every time you got a function, that function takes some string that it needs to use and does not need to store that string in any way, shape, or form, because it's a parsing function like here. Just take a string view instead.
Okay, that's enlightening. I'll definitely look for places where I do not store the string being handed over and where it might make sense to actually not build the strings. Thank you very much, Pepe. That was truly enlightening. I will add QString view to my toolbox now and be thinking more careful about the APIs that I'll be developing there, and I'm sure that the viewers here will do the same thing. So that's your claim to fame in this world, that you made us think more careful about that. I will, on the other hand, also sleep much better at night now, not knowing that if I do not put QString view, QString literal, QString whatever throughout all of my code base and think careful about that throughout all of my day, then I'm not doing things wrong, at least in 95% of the case. But that's not it. Next week's episode, I'll talk to Pepe again. And in that episode, we'll look at a small class called QString Builder, which will make concatenations of string slightly or much, I don't know, faster. It's in any case a pretty cheap one to add. So do tune back in next week. Thank you very much, Pepe. It was a joy to have you with me in this episode again.